Today we learned about two types of lines. We first of all learned about parallel lines. When you look at parallel lines like on a graph, you'll know they're parallel because they never intersect. That's how we visually tell that they're parallel, is because they never intersect. What that means about the lines is that they have the same slope. That's what that means to be parallels. The lines have the same slope. So for example, a line such as y equals 3x plus 4 and y equals 3x plus 2. These two lines are going to be parallel because the slope, the number here in front of x, in both of them is a 3. So that's what makes them parallel. We also learned about perpendicular lines. So when you graph perpendicular lines, they intersect to form a 90-degree angle. So this angle here in the middle is going to be 90 degrees. So they intersect and form 90-degree angles. That's how you graphically know if they are parallel, if they are perpendicular. But as far as the slopes go, the slopes are mathematically what we call opposite reciprocals. They're called opposite reciprocals. And we often simplify that to be the idea of the flip and switch. It is the flip and switch. Also remember that this is the symbol for perpendicular lines. So when we say the flip and switch, then we mean that a slope of 2 over 5 is going to be perpendicular to a slope of negative 5 over 2. So two things happen. First of all, we flip the fraction, so it was 2 over 5, now it's 5 over 2, so we turn it upside down, and then we switch it, which means we switch the sign. So another pair of perpendicular lines would be the pair for negative 4/3 would be perpendicular to positive 3 over 4. And then a third set of perpendicular lines would be 1/2 would be perpendicular to negative 2 over 1. 1/2 would be perpendicular to negative 2 over 1. And then a fourth set would be that 4 is going to be perpendicular to negative 1/4. So keep in mind that if I have a number that doesn't have a fraction, I can put a 1 in the denominator so that I can actually flip that fraction. So it's important to remember that the equation of all lines is in the form y equals mx plus b. And if I need to determine whether the lines are parallel, perpendicular, or neither, I'm looking at my slope. That's what matters here, is my slope. So if I have the example problem, y equals 4x plus 5 and y equals 4x minus 2, and I want to determine if they're parallel, perpendicular, or neither. I'm going to look at the number in front of x, which in this case both of them are 4. So since both of those are 4, that tells me that my lines are parallel because those slopes are the same. So I have 3x plus 4y equals 16 and 8x minus 6y equals 24. I need to decide if these lines are parallel, perpendicular, or neither. So first thing I'm going to do is I'm going to solve each of them for y. So I'm going to begin with 3x plus 4y equals 16. So I'm going to draw my line, label my sides. Y is on one side, everything else on the other. So this 3x needs to move, so it's going to become a minus 3x, and then it's gone. And then to get rid of the 4, I'm going to divide everything by 4. So I end up with the equation y equals, and that 4 is gone by the way, y equals 4 minus 3 over 4x. That's my first equation. So I also have the equation 8x minus 6y equals 24. So I'm going to draw my line, label my sides. Y is on one side, everything else on the other. So I need to get rid of this 8x over here. That's the first thing that needs to go. It was positive, so I'm going to make it negative 8x on the other side. And then I need to get rid of the negative 6 in front of y, so I'm going to divide everything by negative 6. So that's gone. I end up with y equals negative 4, and negative 8 over a negative 6 is a positive. 8 over 6 reduces to 4/3 x. So looking back at my two equations, in order to determine whether they are parallel, perpendicular, or neither, again I need to look at the slopes, which is the numbers in front of x. So this one on the left has a slope of negative 3 over 4. The one on the right has a slope of positive 4 over 3. Well, if you look at your slopes, you should notice a couple things. You should notice that this one is 3 over 4. This one is 4 over 3, so it's flipped. This one's negative, this one's positive, so it's switched. That tells us that our lines are perpendicular. That tells us that our lines are perpendicular. We can also verify that graphically or numerically, because if they're perpendicular, that also means that when you multiply the two slopes together, you're going to equal -1. If you multiply the slopes together, it should equal -1. So I had slopes of -3 over 4 and a slope of +4 over 3. So I'm going to multiply. When I multiplied fractions, I multiplied tops. So -3 times 4 is -12. And I multiply bottoms. 4 times 3 is +12. And if I divide a -12 by a +12, I get -1. So since it was -1, that again verified that they were in fact perpendicular. So I have two sets of points. I need to decide if these points are parallel, perpendicular, or neither. So I could use stat edit. That'd be a really easy way to find my slopes. I could also use my slope formula, which is y2 minus y1 divided by x2 minus x1. So that's what I'm going to do here just for practice. So I have my fraction line. I'm going to put all my parentheses in place and my minus signs. And now I'm just filling in my numbers. Remember, my y's go on top, which are 5 and 7. Put 5 and 7 on top, and then on the bottom in my denominator I put my x's, which is -2 and 3. So on the top I have 5 minus 7, which is -2. On the bottom I have -2 minus 3, which is -5. And a -2 divided by a -5 is a +2 over 5. So I have my second set of points, 4, 1, and 6, 6. Again, I'm going to draw my fraction, put my parentheses in so I can just fill in my numbers. My y's go on top, which are 1 and 6. And then my x's go on bottom, which are 4 and 6. So on top I have 1 minus 6, which is -5. On bottom I have 4 minus 6, which is -2. And a -5 over a -2 is a +5 over 2. So these two lines produce two slopes. One produced a slope of 2 over 5. One produced a slope of 5 over 2. In order for them to be parallel, they must be the same. Well, if you look at the slopes, one's 2 over 5, the other's 5 over 2. So that option is out. We can eliminate that. In order for them to be perpendicular, they must be flipped and switched. So if we look at our slopes, we have one is 2 over 5, the other is 5 over 2. So that takes care of the flip part. That is true. But the switch part here, remember, that means they must be opposite signs. Well, 2 over 5 is positive and 5 over 2 is positive. So that tells us they're not flipped and switched, so they're not perpendicular. We can also verify that mathematically because we can multiply. We can take 2 over 5 and multiply it by 5 over 2. When I multiply fractions, I multiply tops. 2 times 5 is 10. 5 times 2 is 10. 10 divided by 10 is 1. If they were perpendicular, then they would equal -1. If they were perpendicular, they would equal -1. And they don't, so they're not perpendicular. They equal +1. Since they're not parallel and they're not perpendicular, that tells us that these two lines have a slope of neither. They are neither parallel nor are they perpendicular. And last thing you need to remember is that if you have two lines that are vertical or horizontal, or any line that's vertical or horizontal, it doesn't necessarily have to be two of them. If it's a horizontal line, the slope is 0. And the equation of this line is always the form y equals some number. The equation of that line is always in the form y equals some number because it crosses the y-axis at whatever that number is right there. If you have a vertical line, its slope is always undefined because up and down is undefined, and its equation is always x equals some number every time because it touches the x-axis. This is the x-axis, and this line touches the x-axis at some value.